Today's video will be looking at problem 207, course schedule. As usual, the 3 steps of solving any problem are 1. Understand it, 2. Visualize it, and 3. Implement. So, there are a total of num courses. So num courses you have to take, labeled from 0 to num courses minus 1. You're given an array prerequisites where prerequisites I is A1, B1, indicates that you must take course B1 first if you want to take course A. So we have these nested arrays that are of size 2. The leftmost value is the course, and the right value is its prerequisite. So you need to take this course before you take that course. And here this example, pair 0, 1, in case that that to take course 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. So example 1, our prerequisites are, so you need to take course 1, but first you need to take course 0, and we're not seeing any requirements about course 0, so we can go ahead and take that. Once we've taken that course, we can go ahead and take course 1, so the output is true. In this case, 1, 0, and 0, 1. So to take course 1, you need to take course 0, but in order to take course 0, we need to take course 1. So there you have a loop, and we just can't, fulfill, complete all the courses. So constraints, num courses is between 1 and 2,000 courses. There are between 0 and 5,000 arrays of prerequisites. So that means courses with prerequisites, and the length. So the length of this array will be 2. So course and prerequisite, and A and B are between 0 and num courses, and all the pairs prerequisites I are unique, so they won't duplicate like 1, 0 and then 1, 0 again. Like this. Like that won't happen. So let's start with I think this one's pretty clear, and let's just visualize this one more time. So there you have 1 needs course 0, 0 needs course 1. So I think it's pretty clear. So the fundamental concept that you need to understand is topological sort. So this is just a nice tool to add to your toolkit. And the idea is first, so what are the basic truths we know? We know that we know the number of courses, so this should go 1 and 0, because it's up to num courses minus 1. And we know that if a prerequisite is, if we don't have any prerequisites for a given number, that means it has no prerequisites. So you're going to take a course. Let's say you're going to school and a class doesn't have any prerequisites, you can go ahead and take it. And we can also figure out, for every prerequisite, like which courses it corresponds to. So you want to go start with like the classes that don't have any prerequisites, and then you want to go through each of those and see which ones only have that, which courses you can take next based on the prerequisites you've completed. That is the fundamental idea around how solve this problem. So in graph terms, the idea of mapping prerequisites to which courses you can take next, we can use what's called an adjacency list, where you have a node, so that's your prerequisite, and it corresponds to a whole number of neighbors, which are the courses that you can take next. And then the concept of you're going to school for the first time and you see a class that doesn't have any prerequisites. So that's a case where in a graph theory, you can say that it has 0 in degrees, meaning that in this context that it doesn't have any requirements, you can go ahead and take it. So that's how we want to bring it into that kind of like graph theory, terminology, but it's all based on ordinary day-to-day approach to, like, I go to school, I'll take the classes that don't have prerequisites, and then once I've completed those prerequisites, I'll see what classes I can take next. That's literally all there is to it. So let's create our adjacency list. It'll be this new map, and we'll also create a in degrees, which will be an array of size num courses. Fill this with 0, so just a whole bunch of zeros. And so every time that we notice that a course has a prerequisite, we'll increase the in degrees, meaning that it has one more class that needs to be taken before you can take that class. And we can just iterate over our course and prerequisites. And let me double check that I have the right order. You have to take course 0. In order to take course 0, you have to first take course 1. So yeah, course and prerequisite. So we want to both fill up the adjacency list and in degrees. So in degrees are simple. You just say, let's take this course. This course has, one more prerequisite because, appeared in this prerequisites array. And then to build the adjacency list, if edge list dot has, let's call this prereq. So ignore that case for now. Let me just do the else statement. So if there's no prerequisites, edge list dot set prereq to, we can either use a set or an array. I guess I'll use a set dot add the course. So this means that this prerequisite will point to, a set of values which are the courses. And in this case, if we see the same prerequisite again, we can then say edge list dot set prereq to edge list dot get prereq dot add course. And you can take a look at what this looks like. Edge list and degrees. So you can see course 0 doesn't have any prerequisites. Course 1 does have a prerequisite, as we see here. And then we see that this 0 prerequisite, it goes to course. So once you complete this course, then you can take this course. And so at this point, what you need to do is to start iterating, and keep iterating through the classes that. So first let's get a list of all the classes that don't need prerequisites, and the strategy you want to take is a breadth first search. It's a standard approach to solving topological sort, because the reason being that we can start off with the classes that we know don't have any prerequisites and put those into our queue, and then once we cycle through those and we've figured out that some new courses are now allowed to be taken because we completed the prerequisites in the previous queue, then if we just keep iterating on that, we will cycle through all the possible courses and prerequisites. And so the questions say return true, you can finish all the courses. Then we just say if the number of courses equal to the number of courses that we traversed, and then we have our final solution. So let's do so the queue. Once again, we want to just get all the courses that don't have prerequisites. So for let I 0, I is less than in degrees length I plus plus. If in degrees I equals 0, so no prerequisites, queue dot push I. Okay, and now we have our queue. So let me show you what the queue looks like, and we can clear that guy out. So yeah, 0. And the way breadth first search, it's like a while loop. Queue.length, we grab the, this last in first out. We grab the first element in the queue, and we're gonna keep track of all the classes that we've accounted for. And then so what we'll do is we keep adding the classes that we've accounted for into this result. So result will be push cur, and then we will return result.length equals num courses. So if we are able to cycle through all the courses, and we know that that all the pairs are unique, then we know that num courses should equal to results.length. So we'll have 0 and 1 in the end, and that length is 2, num courses is 2. That will return true. Okay, so result.push cur, and then now we can look at, remember how we created these adjacency lists where prerequisites like tell you like which courses it will allow you to then take. So we can like check out that map. If AgileList.has cur, then we can cycle through those. We call them neighbors for let neighbor of AgileList.get cur. And some of these courses may need like a whole bunch of prerequisites, so we're not sure 100% yet. But we can know is that one more prerequisite was taken care of, and so its in degrees will go down by 1. So in degrees, the neighbor will go down by 1. And let's say that value is now 0, like there's no more prerequisites. That means that we are 100% ready to be able to take that course, and we can push it into the queue. And I think that is all there is to it. Let's see how this guy does. Let's use example cases. And let me get rid of my log and submit. And there you have it. That's a course schedule using topological search. And catch you later. Thank you.